Okay, I think we're good now. Okay. We're gonna move on to the practice ones here. So we're given a graph at the bottom that I gave you, right? There's a giant graph here. And I would like you to practice the x and y intercepts and use them to graph each line. I'll go through the first one together one more time, and I would like you to try the next two on your own. I'll give you around 5 minutes to do so, and then we will take it up. Okay? So let's zoom into the first question here. So it doesn't really matter what you solve for first. Like if you want to solve for your x-intercept first, you can do that. If you want to solve for your y-intercept first, you can do that. So here, I usually just go for x-intercept first. So y equals 0. I plug that in. 4x plus 6 times 0 equals 24. We can cross that out because 6 times 0 is 0. We're left with 4x equals 24. We divide both sides by 4, and we're left with x equals 6. So my x-intercept is 6, 0. We go right down to the bottom here, and we can plot that point right there, 6, 0. We then move on to the second part, which is our y-intercept, where x equals 0. If you want to make it faster, you're like, oh, x is 0, cross that out from the equation. Sure, you can do that. And that can jump you right ahead into 6y equals 24. Solving for y, we can divide by 6, and we'll get y equals 4. So my y-intercept that I will get is 0, 4. Okay, so I've skipped the step here. Instead of plugging it in, I'm saying, oh, x is 0, so this whole part is gone. Only left with this part of the equation. That's essentially what I'm saying here. Okay. Okay, so we're going to keep going on here. There's Kuzli. Okay. So we have 0, 4. We're going to plot that point on here. Right? And then we can connect that with the straight line. Just like that. And we can extend that much longer. Make that nice and long. And then fill that in. Boom. And so there's our line for the first one. It's okay, Kuzli. You just got to play a little bit of catch up. Okay. So I'm going to zoom out here so that you can see the whole screen. And then I'll give you 5 minutes to try the next two. Use this as a guideline to solve for the next two, and we'll take it up in 5 minutes.
Hello.
Yes, James.
So we're solving for the next two, right?
Yes, you're solving for the next two and graphing it down here.
Got it. Thanks.
Yes? All right. If you have any questions, once again, please let me know. And Kuzli, if you came in, if you're not sure, if you need me to scroll up a little bit, just let me know. Can the answer be a fraction? Yes, absolutely, it can be a fraction. Okay, I want you to finish up whatever you are writing. We got around a minute left, and then we're going to take it up. I'll do the second question in red and the third question in orange. Okay, let's take this up. So second question I'll be doing in red. So here, 6x minus 3y equals 15. We solve for our x-intercept first. Y is equal to 0. And so we can plug it in and say, oh, that's 3 times 0 equals 15, and say 3 times 0 is gone. We don't care about that anymore. We're left with 6x equals 15. Then we get rid of the 6, we divide by 6 on both sides, and we get 15 over 6. This is not nice. We don't like this, right, as a fraction, but we work with what we got. We can simplify this fraction, and when you simplify it by dividing by 3, you should be left with 5 over 2. Some of you may have already divided this and said it was 2.5, which is fine. It's a very short decimal, that's fine. So our x-intercept would be 5 over 2 comma 0 or 2.5 comma 0, whichever one you did. Now for the y-intercepts, we're going to be doing x equals 0, and we can say 6 times 0 minus 3y equals 15. 6 times 0 is gone. We're left with negative 3y equals 15. We divide both sides by negative 3, and y is going to give us negative 5. And so there's going to be my y-intercept, 0, negative 5. Plotting these 2 points on the graph below, I'm going to zoom out just a little bit. We start with the x-intercepts, 5 over 2, 0, or 2.5, 0. That's going to be right here. Okay, so 2.5, 0. And for the y-intercept is 0, negative 5. So we're going to go down to negative 5 on the y-axis. We now have our 2 points. We can now graph it. Just like that. And extend the line further. Something like that. And then let's pick a color. And let's make it bigger. Just like that. Boom. And there's our red line. Okay. So we have our red line here. Just like so. So hopefully you got that correctly. To draw the points in, write the points in here. This would be 5 over 2, 0, and this is 0, negative 5. Our last one here. So our last one on the right side here, we're going to solve this one, which is x-intercept. So y equals 0. And this one, you'll notice it's in y equals mx plus b form, which is the slope y-intercept form. And so we plug in 0 on the left side, and we can solve for x, right? We can't just get rid of it in this situation. Like, we can't just say, oh, I can ignore that, and we're left with just 4x minus 8. We got to remember the equal sign is still there. So we get 0 equals 4x minus 8. We do BEDMAS backwards. The negative 8 moves to the other side. We get 8 is equal to 4x. And then we can divide both sides by 4. And we're going to get 2 is equal to x. So my x-intercept is going to be 2, 0. I'm going to scroll down. I'm actually going to plot that first. I should have done that for the previous question, so I'm going to do it now. So I plot the x-intercept, 2, 0. For the y-intercept here, I'm going to plug in x equals 0. And this one here, we can actually just cross that out if we'd like. And we're actually going to be left with y equals negative 8, which is very easy because we're done. And we're left with 0 minus 8 as our y-intercept. And that we're going to plot that down here. And we're going to connect it with a line. So my line is going to connect like so. These 2 points get connected. I can zoom out and extend these 2 lines even further. Just like that. And use my orange line to indicate it. If I write the coordinates of my 2 points, this will be 2, 0, and this would be 0, negative 8. And there's our full solution for our 3 lines. Are there any questions, or would anyone like me to clarify these questions? All right, looks like there's no questions of clarification. So we're going to continue on here. Okay. All right. So moving on, we have our last page here. It says to find the slope using the slope formula. So the slope formula, we already know it. And in case you don't remember it, it's m is equal to y2 minus y1 over x2 minus x1. And that should be a 2. So y2 minus y1 over x2 minus x1. If it tells us that these are the 2 x and y intercepts, the x-intercepts, we're going to write it as a point. And the y-intercept, we're going to write it as a point like so. and we can say, oh, x1 is 5, y1 is 0, x2 is 0, and y2 is -1. Right? So at the end of the day, whenever we have to solve for a slope, right? Whenever we have to solve for a slope, we always want to write down the coordinates of our 2 points and then identify the 4 important pieces of information, x1, y1, x2, y2. Once we get those 4 points of information down, we can then plug it into our formula. And so we get y2 is -1, y1 is 0, x2 is 0, and x1 is 5. Solving this out, I will get -1 over -5, which simplifies to 1 over 5. And there's our final answer. M is equal to 1 over 5. Okay? So this is how you're going to solve this. Okay? I want you to try question B on your own in a bit. Give me 1 second before you do that. Let's look at question C and D, though. Question C says the x-intercept is none. There is no x-intercept, but there is a y-intercept. If there is no x-intercept, which means it never crosses the x-axis, there's only one situation. If I have a situation like this, that's right, it's a straight horizontal line, and because the y-intercept is -1, it does something down here, right? So as a result, the slope here is 0. It's a flat line. And this one here, for question D, the x-intercept, okay, I'm just going to draw this here, and it's saying this point here is 0, -1. For this one here, if we were to graph it, we have the x-intercept as -3, which we can say, oh, that's -3, 0. And the line does not have a y-intercept, which means this one does this. It's a straight vertical line, like such. And so once we have that vertical line, we can say, oh, that's undefined, right? These are our 2 special situations, and this is me trying to get you to remember, hey, remember these 2 slopes? You can't solve it, so it's undefined. Okay? So these are the 2 special cases. So I'm going to give you 2 minutes until 2:30 to solve for question B. Please give me the slope for question B, and then we'll take it up. 1 minute left now because it's 2:29. Okay, it is 2:30. Hopefully you guys are almost finished. I know that was a lot shorter because time. But let's do this. So x equals -7. That's 7, 0. For y-intercept 14, that's 0, 14. So x1 equals 7, y1 equals 0, x2 equals 0, y2 equals 14. Plugging it into my formula, I'm going to get 14 minus 0 over 0 minus 7. And that's going to be 14 over -7. To simplify this, you should get m is equal to -2 as your final answer. Okay, so m is equal to -2 should be your final answer. Okay. Any questions? Clarification? Want me to go through it again?
Are we still solving for B?
I just took
Or
it
you
up,
just
Jane.
You did.
Okay, looks like there's no questions. So we're going to leave this one there. I'm going to start sharing the next one that we're going to be doing today for the next 30 minutes. You'll notice at the end of that page is a homework pages from your textbook. Please take a look on that, as well as there's extra practice that I'm uploading every day along with the worksheet, so please check those. Okay. Next one we're going to do is 3.2 parallel and perpendicular lines. Okay. So this is going to be a little bit different on how we're going to do this today. I'm showing you my screen with parallel and perpendicular lines. You'll notice that this says introductory homework. So the introductory homework was supposed to be done. I wasn't thinking that we were going to go 2 lessons for the 3.1. So you're going to do this now. So I'm going to give you around 10-15 minutes to try this introductory homework. Okay. I'm going to give you 10-15 minutes to try this introductory homework, and then we're going to take it up. Actually, let me think this through. Yeah. I'm going to give you 10-15 minutes to try solving these 3 questions, graph it, fill in the blanks, okay? And then we're going to take it up together to class. All right? So everyone should be trying these 3. It is part of the lesson package for 3.2. It is on Google Classroom, so please go print it or do whatever you need to, download it, whatever it may be, and solve these 3 questions. No, 14. So this 14th and 15th, which is the Thursday and Friday, is test review. It's not the test. The test is next Monday. If I check the calendar, I'm pretty sure I said the test is next Monday or Tuesday. I think so. Let me double check. Yeah. So we might actually be changing the Thursday to a lesson instead, but we'll see. Because I do want to spread it out a little bit. Because you guys no longer have EQAO or anything like that. Yeah, so the test is next Monday. So 1 week from now, we have this test. Okay, giving you guys another 5 minutes to finish off, and then we'll take it up. If you're done, just relax, chill. Okay, let's take this up. So it says to graph each pairs of lines on the same set of axes. So I'm going to be doing the left one in black and the right one in red. So for the left one here, once again, we always start, if we're giving the slope intercept form, we start with the y-intercept. This is b equals -5. So we draw that point first, and then we work on using the slope, because we know the slope is 3/4. So the rise is 3 and the run is 4. We should get this point here. So up 3, right 4 ends up there. Okay. Then we do it again, up 3, right 4. We end up here, and we get this line there. Okay. Now, For the other one, the b value here is 0. And the slope is the same. So up 3, right 4, up 3, right 4. If I draw in these lines, I'll do my best to draw them. Okay. So drawing these lines in, I get this one, and I'll get this one. And can someone type in chat for me? What are these lines? These lines are, what did you write in the blank? What did someone write in the blank? Yes, parallel. Okay. And in the equations of the lines, very good, Ali and Mersel, we notice that the slopes are the same. Okay. So you'll notice these two lines are parallel, the slopes are the same. That's the main important part we want to get here. Okay. For number 2, we'll notice, oh, that's not good. We don't have y-intercept form, but does that stop us from doing anything? Absolutely not. So here, graph each pairs of lines. We start with the y-intercept again, which is 6. We plot the 6 point here. So y equals 6 over there. And then we use the slope -3, which is -3 over 1. So down 3, right 1. And so we're going to end up here. We do it again, and we can do it one more time. And there's our line. For this one here, depending on how you solved it, right, you still get the same answer, but the method might be different. Some of you may have rearranged this equation. If you rearrange the equation, you should have gotten y is equal to -3x. Oh, sorry. Y equals -3x plus, and I get plus 8. And that would end up with something like this as the red line. If you didn't do that, maybe you plugged in and said, I'm going to solve for my x-intercept and y-intercept, right? It doesn't matter which way you did it, you should get the same answer anyways. And this one as well, you should notice that these two lines are parallel again. And once again, I noticed that the slopes are the same. And the last one here, it says graph each pair of lines. We start with the +4 for the first line. We do the slope 5 over 2, so up 5, 1, 2, 3, 4, 5, and 2 to the right. We can't go again on that direction, so we're going to go the opposite way, 2 left, and 1, 2, 3, 4, 5 down. And we get this line here. We get our 3 points. For the second one, we start with -3. And it says it's -2 over 5. So down 2, right 5. Down 2, right 5. And we get something like that. This one I am going to fill in with the line because I do want you to visualize this. So I'm going to draw in this one here in black. And then let's copy that down, and then we'll draw it in red after. Something like that. And we're going to draw it in red. These lines are, what do you notice? You should have written that they are perpendicular. For those that don't remember these two words, parallel means that the lines will never meet. They never touch. Perpendicular, on the other hand, means that the lines cross and make 90 degrees. So here, this angle here, wow, that's terrible. This angle here is 90 degrees. Okay, so this is what it means by perpendicular. What do you notice about the equations of the length? Anyone know what did they write here? Does someone have anything that they wrote here? Slopes are not the same. Yeah, that's right. But look a little similar, don't they? They use the same numbers, 5 and 2, and the signs are flipped. So let's take a look at that, okay? Let's take a look at that. So we're going to dive into that today. So 3.2 here, part A, when if we are to graph all of this, right? So 3x plus 7, 3x minus 7, and 3x. I'll do red, black, red, and orange. So 3x plus 7, we have a line that does this. For 3x minus 7, oops, that's not 7. We have something that does this. And for 3x, we have something that does this. So that's in red, orange, sorry, that's in black, that's in red, and then this is in orange. So we have our 3 and we graph them. And we can clearly see, we notice the lines never meet. Or you can say touch. Or you can say cross each other, right? So the lines never meet, they don't touch. And how are the slopes of the lines related? All the slopes are the same. So this is the main thing here, right? We call the lines never meeting, right? We can say that they are parallel, right? This is parallel. And they never meet. All the slopes are the same. You'll notice here, boom. All of these slopes written inside the equations are all 3. So they're all the same. So this should give you kind of like a light bulb moment. Oh, when the slopes are the same, that must mean they are parallel. For part B, let's graph these situations here. We have these two lines here. Y is equal to 3x plus 7, and y is equal to negative 1 over 3x plus 7. So they both start at plus 7. So I'll do the first one in black. So plus 7 is right here, and it's 3x. So we're going to draw out our slope here really quickly. Remember, review this on YouTube because it is uploaded to YouTube if you need to check the work or you want to kind of go back and relearn it. And for the other one, for the red, we also start at y equals 7 here, but it's negative, so we go down 1 and right 3. So this time, this line's going to go a little something like this. And if we were to kind of draw that out, we get a line that does this, and then we get a line that does this. And we can see, oh, that seems to make 90 degrees there, right? It crosses at 90 degrees, and we can clearly see that these two lines are perpendicular. Same thing for the next one. we start at 2. Negative 2 over 5 is down 2, and then right 5. So there's our next one. Down 2, right 5. And then we can go the same thing in the opposite direction like that. And in red, we can do this one. It starts at the origin because the y-intercept is 0 and 5 over 2. So up 5 and right 2, up 5, right 2, down 5, left 2, down 5, left 2. And if we were to connect these lines once again, we get 2 lines that do this. And we get 90 degrees there as well. And so if we measure the angles of the 2 lines, well, we get 90 degrees. The angle between the set of lines is 90 degrees. Therefore, each of lines are perpendicular. Okay, so I'm going to leave that there for people to copy for a little bit because I know graphing can take a little bit longer. I'll zoom out a little more so you can see the above one as well. So I'll leave it on here for a little bit so you can finish copying down. And if anyone wants to finish off number 3, does anyone want to say number 3? What did they notice about each set of lines? The slopes for each set. What's so special about the slopes in this situation? The slopes are definitely not the same, right? When we look at the equations here, the slopes are not the same, right? We're looking at this here, and we're looking at this here, right? Looking at the 2 slopes, they're not the same, but the fractions are flipped. And output's flipped, and they are opposite signs. So when we look at the 2 slopes here, you'll notice, right? For the first set of slopes here, 3 flipped would be 1 over 3, and the first one's positive, the second one's negative. Same thing on this side here. The fraction is flipped. The first slope is negative, but the second slope is positive. So they have opposite signs, and the fractions seem to be flipped. Okay? So let's look into this, the rules here. Let's look into the rules here. Okay? We're going to skip over. Oh, this got copied twice, huh? Oopsies. Ignore this. Ignore that. So now let's look at the slopes of line A1 and A2 and B1, B2, and let's compare them. So A1 and A2, the slope, so for A1, the slope is 3. For A2, the slope is -1 over 3. So if we try to multiply these slopes together, 3 times -1 over 3 is going to give me -3 over 3, which gives me -1. Let's try the same thing for B1 and B2. For B1, the slope is -2 over 5. For B2, the slope is 5 over 2. And when we multiply these together, I get -10 over 10, which also equals -1. Interesting. Which means, what is the final rule for perpendicular slopes? What can we say about the slope here? Well, that's when you look at the line. That's when you look at the graph. What about the slopes in particular? So you are right. They have to cross at 90 degrees. That's if you're looking at the two lines on a graph. What about the slopes? Looking at the slopes. Two lines are perpendicular if the slopes, two slopes, multiply to give -1. And that's the important part here. Okay? And I'm going to bold that and make that bigger. Okay? The two lines are perpendicular if the two slopes multiply to give -1. There's another way you can visualize it. If you don't want to multiply them and you can visually see them, we're going to go through that. So we're going to conclude with this. Parallel lines have same slopes. That's for sure. We know that they have the same slope. Perpendicular lines have reciprocal slopes. And this is a special word that says the fraction is flipped. Sorry, I'm going to rewrite that. Negative reciprocal slopes. Okay. So for here, an example would be M1 is equal to M2. So the slope of the first line is equal to the slope of the second line. For the perpendicular lines, it would be the slope of the first one is negative the slope of the second one, where it's flipped in the fraction. The side rule that comes out from this is that if you don't know what that means, if you multiply the two perpendicular slopes, the product should be -1. And this is a really important rule, right? This helps simplify identifying perpendicular lines, but you do have to remember that how to get slope, right? You have to remember, oh, how do I get slope? How can I find slope, right? That's the important part here, okay? So with that, we're going to leave it there. I would like you to try this next page. So page 4, I would like you to try on your own, and we're going to take it up tomorrow. Okay, do not do page 5, just do page 4. So page 4 is homework. Okay, so page 4 of 3.2 is homework. All right, and let's make it another homework check, shall we? I'm going to upload, I'm going to make a Google assignment on Google Classroom, and I'm just going to say page 4 of 3.2, and boom, this is the only page I want to see. I want it completed and uploaded, and then we're going to take it up tomorrow in class. All right? So if you have any questions, please feel free to email me or take a look at the lesson on YouTube, as it is currently streaming and will be done. Okay? So, last but not least, we always have announcements. Yeah, I'm going to post it on Google Classroom. Okay. So, just to make sure we are all on the same page here with this, your test is next Monday. That's number one. Your test is next Monday. Number two, I'm still missing some tests. I talked to the students. I will not say who, obviously, but the students who I've talked to, please hand in your tests as soon as possible because I don't want you to be overwhelmed with other work. Okay.